In Malaysia, soil pollution has become increasingly noticeable over the past decades, especially in areas with rapid urban growth and rising waste generation. One key example is the Sungai Ikan landfill in Kuala Nerus, Terengganu, where researchers found that soil is heavily contaminated with over 3,000 microplastic particles detected in just 1 kilogram of soil. This pollution is strongly linked with improper plastic disposal, increasing industrial manufacturing and expanding urban activities, which contributes to continuous landfill accumulations. Over time, plastic waste breaks down into micro-sized particles that remain in the soil and may carry harmful substances. These are not merely small fragments, but many were less than a millimeter in size and capable of carrying toxic substances such as mercury and arsenic. This reflects how everyday consumption and modern development, while beneficial, also leave long-term environmental footprint beneath our feet.
The main cause for this specific soil pollution that are happening right now in Terengganu is the use of plastics. Plastics packaging are widely used since it is a single-use item and is designed for quick disposal. Therefore, its extensive use has caused the plastic pollution level to rise significantly. Plus, Malaysia also has become one of the top 5 countries in Southeast Asia to produce municipal solid waste the most. On top of that, rapid urbanization and also industrial growth have worsened the environmental degradation, thus increasing the plastic pollution level. All of these factors will lead to soil pollution as the plastic will undergo degradation that will produce microplastics and will be absorbed by the soil later.
Microplastics are now found in the Terengganu beaches, river and soil. In the short term, these tiny plastics are quickly eaten by the small fish, shellfish and plankton. Turtle nesting beach area also get contaminated, affecting the egg survival. In the soil, microplastic will reduce the water absorption and disturb the microorganism like a bacteria and earthworm that will causing the slower plant growth. For communities, the seafood quality will drops and beaches look less attractive to a tourist. In long term, microplastic build up the food chain and can harm the fish, turtles and the whole marine ecosystem. Over the years, this may reduce the fish population and damage the habitats like a seagrass bed and affect the fishermen income. They are also concerned about the human health from long-term seafood exposure. Terengganu depends on the clean beaches, healthy marine life and tourism. If microplastic pollution continue, it threatens both our environment and our community.
Demonstrates 11 soil sampling stations located around the Sungai Ikan landfill in Kuala Nerus, Terengganu. The results show clear variations in microplastic abundance among the sampling sites. Among all these 11 stations that they have done the research, station number 9 recorded the most microplastics, which is 5,715 items per kilogram of dry weight. This was followed by station 11 with 4,920 items per kilogram and station 5 which recorded 4,140 items per kilogram of dry weight. In comparison, Station 2 shows the least number of microplastics with 1,615 items per kilogram of dry weight, followed by Station 4 with 2,345 items per kilogram of dry weight, and lastly Station 7 with 2,350 items per kilogram of dry weight. This data suggests that microplastic distribution around the landfill is uneven. The higher values observed at stations 9, 11 and 5 may be influenced by their proximity to the landfill, surface runoff during rainfall, and surrounding human activities, which can contribute to the accumulation of microplastics in soil.
Shape of microplastic. This figure shows the type of microplastic found in the soil sample. Fragment 34% is the most dominant type, indicate degradation of the larger plastic item due to weathering, UV exposure and mechanical stress, while fiber 34% commonly in textile waste and synthetic fabric. Film 32% likely from plastic bag, packaging or agriculture films. while foam and pellets present in a very small amount, suggesting limited industrial pellet contamination. The dominance of the fragment and fiber suggesting the secondary microplastic formed by the breakdown of the larger plastic waste in the landfill of environment. Size distribution of microplastic. This pie chart shows different size of classes. Type 1, the largest size, 48%. Type 2 and 3 is a moderate. Type 4 and smallest, 5.5. Most microplastics are still relatively large, indicating the early stage of the fragmentation, while the smaller particles suggest ongoing degradation processes. From the EDX elemental analysis, major elements that were detected, which is C and O, which are the plastic polymer structure, and others is heavy metal. Presence of metal suggests the contamination came from the landfill, leachate, industrial, and urban waste.
Hello everyone, today I will be explaining how Terengganu manage soil contamination. I will cover the measures that are already being implemented. The first one is soil quality monitoring. In Terengganu, the Department of Environment (DOE) monitors soil quality through site inspections, soil sampling and pollution investigations, particularly in areas affected by industrial activities, land development and public complaints. Soil assessments are also carried out as a part of Environmental Impact Assessments (EIA) for proposed development projects. These measures help identify contaminated land at an early stage and reduce risk to public health, agricultural productivity and environmental quality. Next is waste management regulations. Under the Environmental Quality Scheduled Waste Regulations 2005, industries in Terengganu are legally required to manage hazardous or scheduled waste in a controlled manner. Terengganu does not have a centralized hazardous waste disposal facility. Therefore, industries must engage licensed waste contractors to collect and transport scheduled waste to DOE-approved treatments and disposal facilities in the other states, such as Kualiti Alam in Negeri Sembilan. All scheduled waste movements are recorded using the DOE's Electronic Scheduled Waste Information Systems, eSWIS. This system ensures proper tracking and prevents illegal dumping, which helps protect soil from long-term contamination.
Next, I will be explaining the future solutions that we can do to reduce soil pollution. First is bioremediation. This method uses effective microorganisms such as bacteria and fungi to break down the pollutants. For example, microbes can degrade petroleum hydrocarbons in oil-contaminated soil into harmless substances like water and carbon dioxide. It is less disruptive compared to removing and transporting the contaminated soil. Next is phytoremediation. Some plant species act as hyperaccumulators, absorbing the heavy metals through their roots and storing them in their tissue. Examples include sunflower and vetiver grass. Once the plants have grown, they are harvested and disposed of safely with the pollutants inside. This method also helps reduce soil erosion. Last but not least is the biochar application. Biochar is a charcoal-like material produced from biomass. It has a highly porous structure that can bind heavy metals and immobilize them in soil. In Malaysia, empty fruit branches from the palm oil industry can be converted into biochar. This approach supports both waste reduction and soil remediation efforts. In summary, the case study reveals that soil in Malaysia, particularly at the Sungai Ikan landfill, is no longer impacted only by visible waste but also by persistent microplastics that continue to fragment and carry toxic compounds. Study reveals that soil is not exempt from the global microplastic crisis. These particles do not simply remain buried, but they continue to degrade, interact with contaminants, and may eventually move into plants, water system, and ultimately human health pathway. Factors such as rapid urbanization, industrial output, and plastic-heavy consumer habits contributes directly to this pollution. Moving forward, addressing soil contamination is crucial for Malaysia's future, as polluted soil affects agricultural security, clean water access, and ecosystem stability. By strengthening waste management system, reducing plastic dependence, and building public awareness, Malaysia can protect its land resources and ensure that development and environmental help progress together and not in conflict.